Welcome back. Today's lesson is section 3-5, proportional and non-proportional relationships. So in this section, we are going to utilize inductive reasoning. Now, the question you ask yourself was, what is inductive reasoning? Inductive reasoning is just using a pattern to find a general rule. So, it's nothing that's really proven. It's just we see a pattern and we create something from it. So if the equation is of the form y equals kx, then the relationship is proportional. Okay, y equals kx, where k is a constant. So let's look at this. So use the table below to show the average amount of gas Rogelio's car uses, depending on how many miles. So we have 1 gallon is 28, 2 is 56, 3 is 84, 4 is 112, and 5 is 140. So graph the data. So I've done that for you here. What conclusion can you make about the relationship between the number of gallons used and the number of miles driven? So if we look at this, when we graph and plug in, if we look at all these numbers, we can see that 1 times 28 is equal to 28. Now, why did I choose 28? Because as I move every time, it's plus 28. Plus 28. I see a common difference. Okay, I see a common difference. So I'm checking 2 times 28, which equals 56. 3 times 28 is equal to 84. All right, and so if I were to take 0 times 28, I would get 0. So another point would be I use 0 gallons, I get 0. If I use 0 gallons, I get 0 miles. So what we can assume is this is, this is proportional. Okay. So write an equation to describe this relationship. So if we're just following that pattern of 0, 28, 56, 84, it looks like we actually start with a y equals 28x, the constant, because I'm always multiplying by x. I'm taking this top value and I'm multiplying by 28, and I'm ending up at the miles driven every time. So I have a proportional relationship. So let's look at it again. So graph the data and describe the relationship between. We're not going to look at the data too much, but let's think. We have plus 7.5, plus 7.5, plus 7.5. So we can see that if we were to graph 7.5 and we get 1, we end up right there. 15 and 2, right about there. 22.5, 3, right about there. So it looks like we have another proportional type of relationship, because we're going to end up going through. If we were to put in 0, it looks like we would go right through that line, that spot there. So once again, this is proportional. And once again, if we look at what are we multiplying by the top number every time to get down here, and it looks like we multiply by 7.5. All right, so we can assume, make a general rule that says it's y equals 7.5x. All right, now some are not proportional. This is where it gets a little bit trickier. Write an equation in function notation. Remember, function notation is just f of x. So instead of y equal, we'll just write f of x. Now it's a little bit different. As we look at this, we see the points here. We go 1, and then we go up to, let's see, 1, 2, 3, 4, 5, and then 7, and then 9, and then 11. So if I were to make a table for these, I get 1, and like 2, and 3, and 4. I'm ending up at 5, 7, 9, and 11. Now this implies I'm okay. So now this is always plus 2. So this implies that we're multiplying by 2. So if I take x and just multiply by 2, I end up with 2, 4, 6, 8. But y is becoming 5, 7, 9, and 11. So on the first line, I multiply by 2, but then how am I getting from 2x to y? Well, 2 to 5, it looks like I'm doing plus 3. 4 to 7, it looks like plus 3. 6 to 9. So it looks like we're taking x, multiplying by 2, and then adding 3 to whatever that comes. So we would say f of x is equal to 2x plus 3. So there would be our equation that is not proportional because it's got an extra addition at the end.